This is Geometry Semester 2 Exam Review. We're going to start with Unit 7. We're going to find the unknown side length. So this is a right triangle. We know two sides, so we can use Pythagorean theorem. So that is hypotenuse squared equals leg squared plus leg squared. It's used to find the missing side of any right triangle when you already know two of those sides. The hypotenuse is across from the 90 degrees. The legs are one of the sides, or are the sides that are perpendicular to each other. We're solving for x. When we subtract 81, and we take the square root, we're going to find out that x equals 12. Which means that 9, 12, 15 is a Pythagorean triple. There are three integers. If you reduce those, 3 goes into all of those. 3, 4, 5. Very common Pythagorean triple. Here we have the same thing. We know two sides. The hypotenuse is our unknown. The leg is 3 squared and 6 squared. It's important to put the x in the correct location. In this case, we're looking for the hypotenuse, so it goes where the hypotenuse is. Over here, we know what the hypotenuse is, but we don't know what one of the legs are. So by using hypotenuse squared equals leg squared plus leg squared, it helps you determine where the unknown is placed. So here, 9 and 36 gives you 45, the square root of 45 to get to x by itself. Then we can break 45 up into 9 times 5. So x equals 3 root 5. That would be called simplest or simplified radical form. Solve the right triangle for the missing side and angle. So we don't know what this side is, and we don't know what these two angles are. So to find our missing side, we can use Pythagorean theorem. The hypotenuse is across from the 90. So our 14 squared, which is 196, we subtract the 25 from that. So our x is the square root of 171, which is approximately 13.08. Now we need to find the two angles. To find the angles of a right triangle, we can use SOHCAHTOA. So to use SOHCAHTOA, we're solving for the angle, so we're going to use the inverse. If we're going from angle B, we have opposite over hypotenuse. Those are the two numbers that we know. So we're going to use sine inverse of our 5 over 14 So with our calculator, we'll say sine inverse, you should use parentheses, of 5 divided by 14, and that gives us 29.92. It's very important that you are in the correct mode. You have to be in degree mode. This calculator is in degree mode because it has the D on the screen. Graphing calculators, you'll have to hit the mode to see what degree you're in. The measure of angle B equals 20.92 degrees. So to find the measurement of angle A, I know the measurement of angle A plus the measurement of angle B adds up to 90. So the measurement of angle A plus this 20.92 should equal 90. We'll subtract that to the other side, which should give us 69.02. Or 69.08. So we have the measurement of angle A, the measurement of our side, and the measurement of angle B and angle A. We're going to find the area of a right triangle with a hypotenuse of 15 and a leg of 12. Hypotenuse of 15 and a leg of 12. So we're looking for unknown side. So you do recognize that it's a right triangle, and you know two sides. So we have 15 squared, 12 squared, and our unknown length. We're going to subtract the 144 over. So that's going to give us 81. And then we can take the square root of both sides. So our unknown side is 9. Now the reason why we're finding that unknown side is for us to find the area of a right triangle. That is half the base times the height. Our base would be 12 and the height has to be perpendicular to that, so it's 9. So we have our area. These are centimeters squared. The tires of a bicycle have a diameter of 24 inches. So we're going to rotate that wheel many times and see how far that it travels. For us to figure out how far that's going to travel, we're going to need to figure out the circumference. C equals diameter times pi. So the circumference is going to equal the diameter times pi. That would be your exact answer. And a rounded version of that would be approximately 75.40 inches. So now if we roll the tire once, one rotation gives us 75. We're going to rotate it 120 times. So we'll take 75.40 and times that by 120. We come up with 9,047 inches, 0.49. Those are inches. If we divide that by 12, we'll figure out that we had 9047 divided by 12 is going to give us 753.98 feet. We're going to decide whether the numbers can represent the lengths of a triangle. So first of all, to determine if it can make a triangle, we need to know that the longest side has to be less than the sum of the other two. So we're going to take the 26 and the 35. We get 61. Well, 61 is not greater than 62. So in other words, those sides would never touch and make the triangle point. Together, they're not long enough to even make the third side. So not a triangle. We can't determine if it's right, acute, or obtuse because it's not even a triangle. Number 7. 5 plus 7 equals 12. We know that 12 is greater than 9. So the sum of the two small sides is bigger than the longest. So yes, a triangle. So now to determine what type of triangle it is, we're going to use 9 squared. We're going to compare that with 7 squared and 5 squared. You want your hypotenuse to be first, or the longest side to be first. So we've got 81 and 72. So 81 is greater, the hypotenuse is greater than the square of the other two sides. So in this case, greater means obtuse. So we take the two small sides, and we see 30 plus 16 adds up to be 46. 46 is definitely bigger than 34. So yes, we have a triangle. We're going to take the 34 squared and compare that with the 30 squared and the 16 squared. So 34 squared is 1,156. 30 squared is 900. 16 squared is the 256. Added to the 900, that equals our 1156. So we have a right triangle because it's equal. For it to be right, the hypotenuse squared has to equal the other two sides. To be acute, the hypotenuse squared has to be less than the other two sides squared. And to be obtuse, it has to be greater than. But to just make a triangle, you have to follow this formula where the longest side, just the number itself, has to be less than the sum of the other two sides, or it doesn't even make a triangle. Number 9. We have special right triangles. We have a 45, 45, 90 triangle that has a formula where the hypotenuse equals the leg times root 2. So this is a 45, 45, 90 triangle because the two acute angles have the same measurement. They would both have to be 45. So we'll put the 5 root 2 here with the hypotenuse because that's across from the 90. The leg is our x, root 2. Divide by the root 2, and in this case, they cross out. So 5 equals x. This is a 90, a 60, so that makes this 30. So here, this special right triangle is a 30, 60, 90 triangle. It has two formulas because the two legs are different lengths. The hypotenuse is the short leg times 2. The long leg equals the short leg times root 3. So we need to figure out what the short leg is for these calculations. They give it to us. Short leg is always across from the 90. So the hypotenuse, x, is going to equal 4 root 3 times 2. When you multiply these, you're going to multiply the same type of number. It's not a square root. So it's the 2 cannot multiply the square root of 3. It has to multiply the front. The y value, which is the long leg, equals the short leg, which is 4 root 3, times root 3. Root 3 times root 3, those are the same types of numbers. That would give you square root of 9, which is 4 times 3, which is 12. So the long leg is 12, the short leg is 4 root 3, and the hypotenuse is 8 root 3. Let's just check for real quick to be sure that 8 square root of 3, we know that the hypotenuse is supposed to be bigger than the other two legs. And 8 root 3 is actually 13, so it's definitely bigger than the other two. Number 11, we see that the two legs are the same length. So if the legs are the same length, then we know that the angles are the same measure, and they would both have to be 45. So this is a 45, 45, 90 triangle. The hypotenuse equals the leg times root 2. The hypotenuse is 7 root 2. The leg is x, and we're supposed to times that by root 2. Well, to get x by itself, we're going to divide by root 2. So x is 7. Well, if you look at the tick marks, I also know that y is 7. Because they're the same measure as x. In this 30, 60, 90 triangle, we have 90 and 30, and if you subtract from 180, you figure out that this is 60. We know that the hypotenuse equals twice the short leg, and the long leg equals the short leg times root 3. Well, if the long leg is 6 root 3, the short leg is x times root 3. We're going to divide by root 3. They cross out here, and in this case they can cross out with the other on the square root of 3. So x is 6. Well, the hypotenuse, remember, is the short leg times 2. So the y value is 6 times 2, which is 12. On the back side, we have a triangle. It's a right triangle. We know that what the three sides are. We're trying to figure out what the sine of r, the cosine of r, and the tangent of r are. So the sine, remember we're going to use SOHCAHTOA. So sine of our angle, we're doing angle r. So that means opposite is over here, adjacent is next to it, and hypotenuse is across from the 90. So sine of r is supposed to be the opposite side divided by the hypotenuse. So that can be reduced down to 3/5, which is also known as 0.6. The cosine of r, which is adjacent over hypotenuse, is 20 over 25. 5 goes in the top number 4 times, 5 goes in the bottom number, which is exactly 0.8. And then the tangent of angle r, the opposite over adjacent, which is 15 over 20, which is 0.75. If we were going to round these to 4 decimal spots, they would just have zeros after them to produce those 4 . Because each of these examples are terminating. The decimal doesn't go on. Use the trigonometric ratio and find the values of the variable. We're trying to find this side. This from the 59 is called the adjacent side. Across from it would be called the opposite side. And of course, across from the 90 would be called the hypotenuse. So using the idea of SOHCAHTOA, from the 59, we're going to look at opposite over adjacent. So the tangent of 59 equals the opposite side over the adjacent side. We put it into a proportion and cross multiply. That's going to give us x times the tangent of 59 equals 17. That's 17 times 1. We'll divide by the tangent of 59, not just 59, but the tangent of 59. So we have 17 divided by the tangent of 59 degrees. That gives us 10.21. Here we're going to find both side C and side D. We're going to have to find them one at a time. From the 39, across from it would be the opposite side. The other leg next to it is going to be called the adjacent side. And of course, across from the 90 is known as the hypotenuse. So you can either solve for C or D. Doesn't matter which one you solve for first. Let's go alphabetical. So C. Well, we have to use one of the sides that we already know. So that's going to be the 37. Opposite over adjacent. That's tangent again. Place it over 1, cross multiply. So we'll take our calculator. 37 divided by the tangent of 39. So when we divide it by the tangent of 39, this should be a 9 here, 39. So that gives us 45.69. Now we could use Pythagorean theorem to solve for the missing side. We could also use SOHCAHTOA. So I'm going to use opposite over hypotenuse, which is known as sine. Sine of 39 equals the opposite side over the hypotenuse. Place that over 1 and cross multiply. We'll divide by the sine of 39. (37) divided by the sine of 39, 58.79. Not just 39, but the sine of 39, and that approximately comes out to be 58.79. So C is going to be 45.69 and 58.79. At 2 o'clock, the shadow of a lighthouse is 19 feet long. The angle of elevation, if you stood at the end of that, it would be 75 degrees apparently to the top of the lighthouse. We're going to figure out the height of this lighthouse. Height has to be perpendicular. We know we have 75 degrees. We're trying to figure out h. So from the 75, we have an adjacent side and we have an opposite side. So we're using SOHCAHTOA. So opposite and adjacent. We're obviously not talking about the hypotenuse, which is across from the 90. So of course we're going to have to use tangent of 75 degrees. The opposite is the h. The adjacent is the 19. So we're going to multiply by the denominator, or another way to think about it is to cross multiply. That brings it over here. So we have 19 tangent of 75 equals h. We get 70.91. And those would be feet. And that's what h should be. We're going to simplify number 17. We're going to rationalize the denominator. The denominator has a square root in it. So to get rid of the square root, I'm going to multiply by a value of 1, which is going to be the root 5 over root 5. The root 5's match. I already have a 3 down there. The root 5, so you get square root of 25. And on top, you just get 18 times the square root of 5. If they're not the same type of number, if they're not both square roots, then you don't multiply the insides with that. But if they are the same type of number, then we can multiply the insides. Well, we have 18 square root 5 and 3 times 5. Well, the 3 and the 18 could have reduced. The value should come out to be 6. So we have 6 square root 5 over 5. This time, we could either rationalize by the denominator right away, or if you wanted to, you could reduce. 4 divides into 12 3 times. So we get 3 over square root of 3. Now we'll multiply by the square root of 3. That gives us 3 root 3 times square root of 9. 3 times 3 is 9. That's going to cross those out completely. So the only answer is the square root of 3. One way to check that is to take 12 and divide that by 4 square root 3. Take the square root of 3 and see if we come up with the exact same answer. None of those numbers change, so yes, they are equivalent to each other. Number 19. Approximate the measure of angle A to the nearest degree. What is the measurement of A? Well, if we use SOHCAHTOA, across from A is the opposite side, next to the A is the adjacent side, and of course across from the 90 is the hypotenuse. We're not using the hypotenuse here because we don't have any other numbers. So hypotenuse is needed for both sine and cosine, so of course I'm using tangent. Tangent of tangent of angle A equals the opposite side over the adjacent side. Well, if I want to find the measurement of that, I'm going to say tangent inverse of 37 over 29 equals the measurement of angle A. So we have second tangent to get the tangent inverse. Got to use parentheses. 37 divided by 29. We get 5191. Here we're going to solve this triangle. That means we're going to find all the side lengths and all the angle measures for this triangle. So because we don't know two sides yet, we cannot use Pythagorean theorem. We have to use SOHCAHTOA. So we're looking at the opposite side. Next to it is the adjacent side. And across from the 90 is the hypotenuse. So from the 51, we're going to look at opposite over hypotenuse. So that sine of 51 equals the opposite side over the hypotenuse, which is dV. We'll cross multiply. dV times the sine of 51 is going to equal 14. Divide by the sine of 51. Divided by the sine of 51. dV equals 18.01. To figure out the other missing side, the adjacent side, MD, we're going to use cosine of 51 is the adjacent side over the hypotenuse, which is this, I guess. But I'm going to change that up. Instead of doing adjacent over hypotenuse, I don't know hypotenuse except I calculated it down here. Let's use the numbers they give us. Let's use opposite over adjacent, and that would be tangent. So tangent, you should get the same answer as long as you're being accurate. 14 over MD. Opposite over adjacent is tangent. Place it over 1 and cross multiply. MD times the tangent of 51 equals 14. Divide by the tangent of 51 because we want to figure out what MD is all by itself. So 14 divided by this, not sine, sorry, tangent of 51. Divided by the tangent of 51. 1134. Notice how the two leg lengths are smaller than the hypotenuse. The measure of M is 90. Measure of angle D is 51. So the measure of angle V, all three add up to 90, or all three add up to 180. Subtract the 90 means that the measurement of angle V plus the measurement of angle D also equals 90. Plug 51 in for D. The measurement of angle V leaves you with 39.